What do you think this is, or might it be? They are among the greatest blasts of radio energy in the whole universe. They produce more energy than a billion suns. The energy in radio frequencies is so powerful that, ultimately, the whole universe will know about this one blast. Cosmic explosion is a very powerful, incredibly bright explosion of a star. It is the greatest blast people can ever see. The final result of a cosmic explosion can either be a neutron star or a black hole, two of the most exotic objects known to humankind. At its peak, a cosmic explosion can be as bright as an entire galaxy, and it can even be so bright as to be visible during the day. It can take years for the brightness of a cosmic explosion to fade. Material several times the mass of the Sun is ejected at speeds of 7% the speed of light in a cosmic explosion. In a span of 100 years, at least 2 to 12 stars should go supernova in our Milky Way, but we haven't seen a star go supernova in our galaxy for the past several centuries, which means we are long overdue for the treat of a supernova impact in our skies. Supernovae are indeed captivating phenomena like no other, so let's embark on a journey to the stars in our Milky Way, which will eventually die in a mesmerizing supernova blast. And consider this. There's one star predicted to go nova before September 2024 itself. Now is the time to explore. Even if a supernova were to occur on the far side of our galaxy, we'd be able to detect it due to the powerful telescopes we now have, which can see farther and fainter. Predicting when a star will go supernova is famously difficult because it's challenging to determine which stars are in the final stages of fusion and which ones have a long time left. There are two possible ways in which a supernova can occur. A supernova can happen in the final stage of a dying star that weighed at least 8 times that of our Sun. Once the fusion process within a star stops, it cannot hold against gravity, and its core suddenly collapses, leading to a spectacular supernova explosion. This type of supernova is known as a core collapse supernova. Many nearby or notable stars fall into the category of stars that can undergo a core collapse supernova. Let's start with the massive blue star Spica. It is the brightest star in the Virgo constellation and one of the 20 brightest stars in the night sky. One fascinating fact about Spica is that it is egg-shaped rather than spherical, like other stars. It is located 250 light-years from us. Then there's the red supergiant Betelgeuse, perhaps the most famous of stars likely to go supernova in the future. Betelgeuse lies in the Orion constellation, about 400 to 500 light-years from us. Next is the red supergiant Antares, the brightest star in the Scorpius constellation. Antares, often referred to as the heart of the Scorpion, is the 15th brightest star in the night sky and is 550 light-years from Earth. Another red supergiant on the list of stars likely to go supernova is VY Canis Majoris, located in the constellation Canis Major, 5,000 light-years away from us. VY Canis Majoris is a binary star system containing one of the largest stars in our galaxy, as large as Jupiter's orbit. Next is the yellow hypergiant Rho Cassiopeiae, in the constellation Cassiopeia. It is around 3,400 light-years from Earth but can still be seen with the naked eye. Rho Cassiopeiae is over 300,000 times more luminous than the Sun. Yellow hypergiants are one of the rarest classes of stars. Only 12 such stars are known in our galaxy. Lastly, there's a star in the Gamma Velorum system. Gamma Velorum is a system of 4 stars in the constellation Vela. Star systems composed of 2 or more stars generally appear as a single star to us on Earth. Night skies, on the grounds that the singular stars in the framework are excessively near one another and excessively far away from us. Gamma Velorum is quite possibly one of the most brilliant stars in our night sky. It is roughly 1,100 light-years from us. One of the 4 stars in this framework is a Wolf-Rayet star, and it is the nearest and most splendid Wolf-Rayet star. Wolf-Rayet stars are very warm, fierce stars. As a matter of fact, they are the hottest type of stars that can ever exist. Their surface temperatures can range from 20,000 to 200,000 Kelvin. For comparison, the surface temperature of our Sun is a mere 5,772 Kelvin. Their extreme temperature means they are thousands of times brighter than our Sun. Their diameter is several times that of our Sun. A few hundred stars of the Wolf-Rayet classification are known, making them a rare class of stars. Apart from that, 4 stars in our Milky Way fall into a unique class of Wolf-Rayet stars, which are stars with dominant emission lines of ionized oxygen in their spectra. All 4 of them are expected to go supernova in the next 1,000 years. The second type of supernova occurs in a binary system. Though our solar system has only one star, our Sun, you'll be surprised to know that most stars exist in binary systems, meaning a system composed of 2 stars orbiting each other. When a mass equivalent to that of the Sun is compressed into a volume as small as Earth, what you get is a white dwarf. This creates a white dwarf, an extremely dense, very hot, dead body of a star that once shone brightly. The extreme density of a white dwarf also supplies it with extreme gravity. In a binary system containing a white dwarf and another star, the white dwarf continues to pull material from its companion, gathering mass. As it keeps stacking up, more and more mass, pressure and heat continue to build until it can hold no more. Then, bang, it explodes in a nova. A nova blast is like a nuclear bomb exploding in space. Identifying binary systems with a white dwarf that could go supernova is much more difficult. Any binary system in which a white dwarf is gathering mass will go supernova, but predicting when it will happen is challenging. The closest known supernova candidate of this kind is Ik Pegasi, located at a distance of 150 light-years, making it perhaps the nearest star system known to go supernova in the future. However, observations suggest it may be as long as 1.9 billion years before the white dwarf can gather the critical mass needed to become a supernova. Another example of a binary system known to be going supernova in the future is Scorpii. It is one of only 10 known recurrent novae in our galaxy. A recurrent nova, as the name suggests, is a nova that erupts at regular intervals, typically every few hundred years. Why does a nova happen? Once the explosion occurs, the binary companion again starts feeding the white dwarf, repeating the cycle. The last explosion of Scorpii was observed in 2022. It is located near the northern edge of the constellation Scorpio, a staggering 64,000 light-years from us. Another of the 10 known recurrent novae of our galaxy that is much in the news these days is T Coronii Borealis. What makes this binary system exceptional is that it is expected to go nova sometime between now and September 2024. Now that deserves a closer look into this extraordinary system. A nova blast will occur soon in our Milky Way, and it will be visible to the naked eye. This nova will occur in the binary system T Coronii Borealis. This system is located in the small constellation Corona Borealis, or the Northern Crown, about 3,000 light-years from us. The T Coronii Borealis system consists of 2 objects: a red giant on the verge of dying and a white dwarf, a dead star. What will this nova look like in our sky? This nova blast will be visible as a new star in our night skies. This new, temporary star will be as bright as the North Star, Polaris, and will be visible for at least a couple of days to the naked eye before dimming down. However, people can observe it for a week or so with binoculars in the night sky. NASA has called it a unique opportunity for people living in the Northern Hemisphere because such binary systems in which a white dwarf is piling up mass from its companion are rare in our galaxy. The T Coronii Borealis system is a known recurrent nova, and the last time an eruption occurred in the star system was in 1946. The next one will happen about 80 years later. Bradley Schaefer, a former professor of physics and astronomy at Louisiana State University, recovered historical records of eruptions of the system and discovered that German monks documented it in 1217 as Signum Mirabile, Latin for marvelous sign. He found another record of this nova being observed by English astronomer Francis Wollaston in 1787. He published these findings in a recent paper in the Journal for the History of Astronomy. Pinpointing exactly when the T Coronii Borealis system will go nova is tricky business. According to calculations, the nova could happen any time between now and September. The new star will reach its peak brightness within 24 hours of the nova blast. It could possibly happen tonight, Schaefer said. More likely, it'll be within the next several months, and probably before the end of September. So go out there, gaze at the night sky, and prepare for the new star that's about to appear. Thank you for joining us on this incredible journey through the universe. Supernovae are truly among the most awe-inspiring phenomena known to humankind, reminding us of the power and mystery that the stars hold. As we await the potential nova in the T Coronii Borealis system, Let's keep our eyes on the skies and our hearts open to the wonders of the universe. Who knows what else the universe has in store for us? If you enjoyed this exploration of the stars, make sure to like, share, and subscribe to our feed for more cosmic adventures. Until next time, keep looking up and stay curious.